Okay, so this is how you do an integral. Next question is, what does it represent on a graph? Well, it's going to represent going from velocity to displacement or going from acceleration to velocity, right? It's going to give you how much of something you have. How much did your velocity change? Well, we can use this instead of, estimating boxes. What it means in terms of kinematic, again, now we can go from acceleration to velocity, velocity to displacement. And we'll learn some other things we can do with it as well later. All right, let's take a stab at an example on the back. It says velocity, I give you a velocity equation. And I ask you about an equation for acceleration, the equation for instantaneous acceleration. Sorry, what is the instantaneous acceleration? 3 seconds of the flight. What's the equation for displacement of the ball relative to the ground? What's the displacement of the ball 5 seconds after it's being thrown relative to the ground level? All right. 0, right? That becomes 0, so it goes away. Same thing is going to happen here. Oops. When I throw 0 in front, this whole thing goes away. And then with an acceleration is equal to -10 meters per second squared. All right? It's constant in this formula, which makes sense because our velocity was a number times t plus another number, v naught plus at. That's what it turns out to be in this case. So we didn't have to use the formula for this one. We're going to. It's a good practice one for it. What's acceleration at 3 seconds? Well, it's constantly 10, so acceleration at 3, there's our new notation. Acceleration at 3 is going to be -10 meters per second squared. What's the equation of the displacement? Yep. What's the equation of... You're good?
Yeah.
What's the equation for the displacement? Well, displacement means we need to go down 1, correct? So we're going to now raise its power by 1, divided by the power I get. This one here, right? Oh, wait, there was a t there. I totally messed that up. So I'm reading my writing wrong. Don't do that at all. That didn't help. Okay, so this is t to the first, so it goes t to the second. -10 out in front, divided by 2 now. Plus 45, it was t to the 0, so it becomes 45 t to the first, divided by 1.
And then do you add the 20?
I add the 20. Why?
Because it's relative to the ground.
It's relative to the ground. By the way, anytime you integrate, hear this is huge. You have to add the initial whatever. If it's distance, you need to add initial displacement, right? If it's velocity, you're going to need to add initial velocity. If it's acceleration, you need to add the initial velocity. Initial acceleration. The reason for that is this. If I give you how fast something's going, can I tell you where it is? Yeah. So when I'm driving, if I get on the phone, pick up the phone and call you up and say I'm going 45 miles per hour, you can tell me where I am? No. You have to know where I was, right, for that to be useful to you, right? And so because you have to know where it was, the initial conditions are not in the rate information. You have to add the initial conditions in because once you turn the rate into a displacement, you also need to add where did you start. And that's going to happen every time you integrate. Every time you increase the power and divide by power, you're going to end up with a constant added on. Make sense? Okay, what's the displacement of a ball 5 seconds later? How am I going to find that? Put in 5. Oh, crud. 45 times 5? Somebody else put that in the calculator? 25, no, it's 20 times 5, so that's 120? Yeah. All right. Everybody try the second example. Okay? Everybody try the second example, and then that's going to be homework tonight to do the second example. But I want 1-6 to go into the homework bin for tonight. And it says 1-5 on the prompt, so it's going to confuse you a little bit. Please put 1-6 in there, okay? Got it?
Both sides 1-6.
Both sides of 1-6. Although you could be 2 different pieces of paper. If you wrote on notebook paper at home, fine. Send me notebook paper. It's my fault. Sort of. Thank you all. Questions from the peanut gallery? Davila, I'll post the 2 teams right after school, okay? Cool. Hopefully Rock and Robot are thinking yay. So go signed off for the doctor. Okay.
That's what I do. Something in 1-6. We have to as well.
Yeah. You have to turn it by midnight. You have to turn it by 3. But every day there's been something to turn in simply because they have to turn things in for almost.
So 1-7, we just do it tomorrow.
1-7, probably we're going to finish it in class tomorrow. Oh, actually, yeah, we're going to finish it tomorrow. That'll probably be tomorrow's homework assignment. But it should be listed when you go to team. It should say what you need to turn in.
Oh,